Hello, good morning, good afternoon, and good evening. On behalf of PioPetro and Millet Research Hub, I'd like to welcome you all in our summer internship program. My name is Mayar Tore, a senior gas and petrochemicals engineering student at PE Egypt Young Professional and I'll be your moderator for today. So before we start, please keep the chat box professional and ethical, and don't forget to drop your questions in the Q&A section below. So without further ado, let's welcome Dr. Ahmed ElZeftawi, Engineer Ahmed ElZeftawi. Engineer Ahmed earned his Bachelor of Science degree in Mechanical Engineering from Cairo University in July 1983, with over 37 years in the oil industry across the Middle East. He has excelled in various key roles. His expertise spans coiled tubing and nitrogen services, encompassing training, supervision, operations, and maintenance. He has also demonstrated proficiency in wireline operations, well testing, completion, and downhole tools, enhancing operational efficiency and performance. Engineer Ahmed's strategic acumen extends to marketing, sales, planning, engineering, project coordination, and science and site management, where he has consistently applied industry best practices to drive successful outcomes. Throughout his career, Engineer Ahmed has been committed to advancing standards in the oil industry through his comprehensive knowledge and leadership, making significant contributions to mechanical engineering and oil sector management. Thank you so much, Engineer Ahmed, for coming today, and the mic is yours.
Thank you, Manal.
Thank you.
Good evening, everyone. Don't believe in what she said. I paid her $100 to say these nice words. Yani.
This is your biography. MashaAllah.
I'm kidding. Well, I have been teaching. It's true. I have been teaching since 1995, and I believe the good thing here for you guys that I am not teaching because I have a master degree in England or any other higher degree in the States. No, I'm just a mechanical engineer. But the nice part is I start my life uh, sweeping the yard and cleaning the tools for my boss till I became director to service companies. And, um, and I'm wearing coverall up till today, I need to witness jobs. And so everything that we will talk about, I see it, saw it by my eyes. I touch it by my hand. I run it in the hole. I pull it out of the hole. I disassemble it in pieces and I put it again. Feel free to ask questions, but I will leave the question to the end of the lecture, where I will put the chat. I will look at the chats and see your question and try to answer it if I can. Uh, I was talking to Dr. Ahmed a while ago, and I said this is my first time that I appear to my audience for the past 35 years wearing a t-shirt. I always wear a tie and a jacket, but this is really the first time I wear a t-shirt. But anyhow, I believe that knowledge is not in the t-shirt or the tie, but it's here. You guys will be with me in 6 lectures. Each one will be for 1 hour. Talk about well intervention. This is not. I won't say this is not a real well intervention course, but it is a very simple one. We will not go through every detail as the real course is, because this will take much time rather than 6 hours here. We're gonna discuss today a course named well intervention. Before we start, we need to ask ourselves what's well intervention and why well intervention. Actually, what's well intervention? I believe it is a science of how to deal with an oil well. Why well intervention? Because we need to avoid disasters that might be created for people that goes to the field to do a certain job and they don't have enough knowledge. Knowledge is really important. Uh, During this course, we will talk a little bit about well control, about risk assessment, about a phenomena called hydrates, about some ways of killing a well. We will talk about what we call mass, which is the maximum allowable annual shut-in pressure. We will talk about very simple calculation, um, uh, how to calculate the pressure and how to calculate the volume. This first three topics represent a chapter we call it completion operation. I believe this will take this session and the following one, which will be Tuesday at this time. Then we will have a complete chapter about completion. We'll talk about completion, the philosophy and design philosophy, and the function of the accessories that we run through the completion. And then we will talk about what we call well intervention. Well intervention services for us is either wireline, coil tubing, or snubbing. In these sessions, we will talk about coil tubing and wireline. We will not discuss snubbing. Um, so we'll go through coil tubing and wireline only. If you see this picture, that's why we say, why will intervention? Why the intervention is we need to avoid seeing this picture because the impact of this picture is life loss, definitely environmental loss, financial loss, reputation. And number five, we call it extra governmental regulation, which means that whenever something wrong happens, we start putting new rules. Yani, to a limit that these days I cannot take a bottle of water with me to the plane. Um, to go to the airport, sometimes I go 4 hours before the airport, before the plane, and I have to pass by maybe 5, 6, 10 checkpoints before I reach there. This makes my life miserable. This is what we call extra governmental regulation. When we go to the field, we care about what we call well integrity. What's well integrity? It is defined as per the North standard as the application of, it's a mixture of three things, as you notice: technical, operational, and organizational solution to reduce the risk of uncontrolled release of hydrocarbons. This is all what we care about. I mean, how to deal with pressure, because hydrocarbons are deep, 10,000, 20,000, and more deep in the earth, and it comes all the way to the surface with pressure. It's very important to know how to deal with this pressure because pressure is a killer, as simple as that. Yeah. And that's why when we are on rig sites, whatever onshore or offshore, we do what we call simulating drills. What is drills? It is a simulating that we try to say, guys, tomorrow at 2 o'clock afternoon, we will have a problem. So tomorrow at 2 o'clock, there will be a bell that sounds in the rig site. And when you hear this bell, each one of you guys has to secure the job he is doing. Then go to the master point. Then tomorrow, when we come at 2 o'clock, when people hear the bell, everyone secure his job, and then go to the master point. Then the safety engineer will go to master point number two. He's supposed to have 10 people. He will look at the list and he will start saying names, and then they will discover that Alex is not there. So where is Alex? Then we start search for Alex. Then Alex, we found him in master point number three. Why, Alex, you went to master point number three? I said, well, I was at the toilet, and when the bell sound, I found that master point number three is nearer. It's near than master point number two. Then we tell him, please, Alex, we will have another one Tuesday at 5 o'clock afternoon. When you hear the bell, wherever you are, please go to master point number one, which is your master point. How to secure the job? This is a philosophy, or as per the design. But the point is, these drills, we keep doing it and we keep repeating it till we have the full satisfaction. Even if we have the full satisfaction, we have to do it in regular basis, at least once a week. Because very simple, if I teach you how to drive and I give you a driving license and you stay 10 years without driving, then I gave you today the keys to drive the car to go home. By the time you reach home, you killed 6 people on the way, right? So we have to practice. So we normally do it at least, these simulating drills, we do it at least once a week. And we normally do it before we start a new job, to be sure that everyone knows what to do if a problem happens. And we also do it when we have a crew change. Because when we have a crew change, people comes from home, they stay 2 weeks, they forgot what oil field look like. So we have to remind them that they have to wear coveralls and safety boot, and so it's very important to do that. But we don't do these drills in critical jobs like perforations. We cannot do drills while perforation. This is ridiculous, yani. But we do it before we start jobs, yes. This statement you see in front of you is a big, big, big issue. The gas behavior. How the gas behave from the time that leaves the reservoir, enter my well, all the way up through the completion till it reaches the surface. What is the behavior of gas bubbles? To be able to answer this question, we have to understand or ask ourselves the gas behavior from deep in the well all the way to the surface depends on the fact that the well is flowing or shut in. And when we talk about the gas behavior, we mean its volume and its pressure. If the well is shut in, the gas bubbles traveling from deep in the well all the way to the surface, these gas bubbles cannot expand, cannot increase in volume, because it is a confined space. The well is shut in. So what happens is, in a shut-in well, the volume does not increase, but the pressure does. Because these gas bubbles, since it cannot increase in volume, it travels upward with its pressure all the way to the surface, creating what we call gas cap. But if the well is flowing, so this gas bubble has the space to increase in volume. If it increases in volume, it does not increase in pressure. And this is what is represents here. To understand the gas behavior, we have to know first the well is flowing or shut down or shut in. If the well is flowing, the volume increases, the pressure does not. On the other side, you see that in case shut in, the volume cannot increase because this is a confined space. Accordingly, the pressure increase because in gas, while traveling all the way up, it creates what we call gas cap at the top. This gas cap increases the pressure. And that's why, if you look at this relationship at the bottom, what is the bottom hole pressure? The bottom hole pressure is the sum of two things: the hydrostatic head above plus the shut-in pressure. And this is also represented by this graph. When you look at this graph that represents in the vertical axis the pressure and on the horizontal axis the time, so the well is flowing with a certain pressure. The moment you shut in the well, you actually converted the case from flowing to static. In flowing condition, what is there in the completion? It is mixed grid. It's actually water, oil, and gas in a mixture. The moment you shut in the well, you convert it into a static. When you convert it into static form, these fluids will separate based on density. So what will be down is water, then you will have oil, then you will have gas at the top. But this separation does not happen in no time. It takes time because there are some gases at 1,000 feet to travel all the way up, creating gas cap. This will take maybe 20 minutes. But some other gases at 5,000 feet maybe will take 1 hour to reach the surface. And some gases at 10,000 feet, they might take 2.5 hours to reach the surface. That's why when we shut in a well, you will see the pressure suddenly goes to maybe 900 psi. Then we go together to the cafe, have a cup of tea together, come back after 1 hour, look at the gauge. You will see the gauge goes to maybe 1,200. Then we grab 2 chairs, sit together by the wellhead, looking at the gauge. You see the gauge go from 1,200 to 1,205, 1,210. And it goes up gradually, maybe till 1,250, and then stop. The moment there is no more increase, we call the well is stabilized, which means the picture below, as we expected, is water at the bottom, oil in the middle, then gas at the top. At this particular moment, the gas is stabilized. Sorry, the well is stabilized. Back to this curve, which represent what we just discussed. Vertical axis is the pressure. Horizontal axis is the time. You will see that well is flowing here. At this point, we shut in the well. What happened? Look at the pressure. it goes all the way up. This first stage, we call it sharp and rapid increase in pressure. Sharp in the increase, rapid in time. This first stage of the curve, this is due to information buildup. This represents when we shut in the well, it goes maybe from 50 psi all the way up to 900 psi in no time. Then from 900 to 910 to 920, this is the second stage, which represents here. This is the second stage up till here, which we call it long and slow. Long in time, slow in the increase. This stage is due to gas migration. The gas traveling all the way up based on the distance. Some gases are 10 feet away, some other gases are 15,000 feet away. So it takes time for them to go up. When the gas go up, it creates gas cap. This gas cap increase surface pressures. Accordingly, increased in bottom hole pressure. Because remember the formula. What is the bottom hole pressure? Is the sum of two pressures. Hydrostatic head plus shut-in pressure. And then the last stage, well, is stabilized heat. No more increase in pressure because gases, all the gases are up to the surface creating this gas cap. This tells us that when you shut in a well, its bottom hole pressure increase. And this is a critical factor you have to consider, because if you increase the bottom hole pressure to the pressure that exceeds in fracture pressure, you're going to fracture formation. If formation is fractured, you damage it. I need to go back here. I just need to be sure that you understand this. In a flowing well, what's the gas behavior on a flowing well? In volume increase, pressure does not. The opposite if you shut in the well. In volume does not increase because it's a confined space. Accordingly, the pressure increase. One of the challenges we face in the oil field industry is what we call surge pressure and swap pressure. What is the swap pressure? The swap pressure happens when you are pulling out of the hole with your tools and you don't have enough clearance between the ID of your tubing and the OD of your tools. If you don't have this enough clearance, when you pull out of the hole fast, you are creating vacuum. The same thing is the surge pressure. The surge pressure happens when you are running in the hole too fast and you don't have enough clearance between the ID of your tubing and the OD of your tools. When you do that, like injection, both injection and vacuum, it hurts your reservoir. And that's why we say the word slow. The word slow in our routine life, it is a disadvantage. But in oil field, this is the word you are looking for. When you run in the hole, slowly. When you pull out of the hole, slowly. When you pressure testing, slowly and in stages. When you bleed off the pressure, slowly and in stages. Have you noticed that? Slowly is the word that attracts you to the good practice you should follow. The word quickly in oil field is a disadvantage actually, and the only time I would remember reading that the word quickly is correct in the API standard is when you close the flowing valve in the Christmas tree. They said close it quickly as soon as possible, but they mention why? To minimize erosion. Because the flowing valve on the Christmas tree, it's a gate valve. You are closing the gate valve against the well pressure, the flow, which is in this direction. So the flow, it erodes the sealing surface of the gate. So that's why you have to close it quickly. Rather than that, please remember that slow is the correct word to use in oil field industry. And talking about bad words and good words, uh, when you deal with the pressure, I don't know what the English word I should use to express that, but if one of you guys come to me and said, Ahmed, I need to borrow 3,000 PSI, what I will do, I will put my hand in my pocket and turn a little bit this, what about 1,000? And then he started saying, oh, it won't work. I need 2,000. I said, well, 1,200 is the maximum I can give you. I'm trying to explain that, please, if you can do the job at 100 PSI, don't do it at 110. If you can do your job at 3,000 PSI, do not do it at 3,100. Pressure is a hazard. This is number one. Number two, pressure creates fatigue to the equipment. So please do not add any excess fatigue without reason. To explain that better, let us go to the API standards, which is American Petroleum Institute. And we teach, by the way, we teach this course as per the American Petroleum Institute. There are so many standards in the oil field industry, but this course, we are teaching it as per an API. When we go to the pressure test, for example, if I have a pressure control equipment, like a BOB, blowout preventer, for example, and I purchased it brand new from the factory in the States, which is rated to 5K, 5,000 PSI. It comes with its certificates. So I will start using it for a period of almost a year. Before the end of the year, I have to recertify this BOB. So what I have to do is I go to a authorized third party who witness the pressure test I will do. When I do the pressure test for this BOB, remember the BOB is rated for 5K, 5,000 PSI. After a year, I need to recertify it. So I will pressure test it in front of the third party to recertify. When I do the pressure test for this BOB, which is rated for 5K, I will do the pressure test up to what PSI? Am I going to do it to 5,000 PSI? Less? More? Think a little bit before I answer, but please think a little bit. From my experience in teaching, yani, some of you will say 5,000. Some of you will say to 80% of this 5,000. Some of you will say more than 5,000. Let us go to the court to decide what's wrong and what's good. Our court in this course is API. If we go to an API, the API tells us that the relation between the test pressure and the working pressure is at least 1.5. So this BOB, which is rated for 5,000 psi, when I do the test for the purpose of certification, I will test it to 7,500 psi at least. If the test pass, the third party will give me a certificate. If you look at this certificates, you will not notice 7,500 psi at all. The certificates will tell you that this BOB is rated for 5K. They might put in the certificates at the bottom with the small letters, test has been carried out as per the API standard. So now the BOB is tested, recertified. Let us take it, go to the field. Let us rig up on a Christmas tree. What is the maximum pressure we can apply to this BOB? The Christmas tree is rated to 100,000. I put it on top of that Christmas tree. What is the maximum pressure I can apply to this BOB? The answer, 5,000. You cannot exceed it. During this year, the tested pressure is the working pressure, maximum working pressure, which is 5K. You cannot exceed that. That's why in one of the questions of the well intervention, which is, I consider it a good question actually. The question say that you rig up your wire line, your E line, electric line equipment on a Christmas tree. You test it to 5,000 psi. You run it in the hole. The hole is full of mud. You reach it 13,000 feet. You perforate. When you perforate, after a very short time, the gauge on the surface reads 5,020. Can you continue the job or not? Before the job, you test your equipment to 5,000 psi. You run in the hole is full of mud. You reach it 13,000 feet, you perforate. After perforation, the surface pressure reaches 5,020. Can you continue the job? Yes or no? I'll give you 30 seconds to think of. Some of you will say, of course we can. It's just 20 psi. To those people, I will tell them, by the way, I need to tell you that 3 psi can kill a man. 3, not 30. The answer is no. You cannot continue the job. Because now you are exposing your pressure control equipment to a pressure higher than the pressure you tested with, or she can work with. Then one of you said, come on, Ahmed. Yesterday we were in the factory and we tested this BOB to 7,500 psi. So definitely it will resist this extra 20. The difference between the 7,500 psi you tested with and the 5,000 psi, which is the maximum working pressure, is not for you to use in the operation. This is to save your life in case of emergency. So even if the pressure after perforation increased to 5,001, I will not continue the job. I cannot. In this course, the problem I used to face with engineers, I used to give them this course because they are from operation side. So when we discuss this issue, always they look at their pockets, they look at the money, how much they're going to lose. But please keep this out of your mind in these courses. In these courses, we care about your life. We don't care about money. Money, budget, promotion, these are bad words. We don't use them. We don't think of. Please keep this in your mind during this course. Money is not an issue. Budget is not an issue. Injury, kill, life, these words that we are care about. So people ask me, of Ahmed, if we cannot continue the job, what should we do now? We are at 13,000 feet. Pressure, as you mentioned, exceed the test pressure we use. So what should we do? And my answer always, guys, please help me. Tell me what to do. Yani, suggest. Then I start hearing these answers. One of them says, if we cannot continue the job, let's pull out of the hole, close with the swap valve, close with the Christmas tree. I said, great, but this will take 2 hours. So in 2 hours, for complete 2 hours, 120 minutes, you are exposing the area to a hazard situation. How come? I need you guys to know that when you have a problem and you need to fix it, you go buy a book from the library, how to solve problem. And then you look at your problem, you will find it in page 20 in this book. Go to page 20. You will find that it explains your problem, which is, yes, this is my problem. Where is the answer about how to solve it? Go to page 21. When you go to page 21, you might find 10 solutions to your problem. Rest assured that solution number 10 is killing the wood. And this book, come on, there is no book look like that. I'm imagining, yeah. The way he gave you the solution, the 10 solutions, solution number 1, you will find it that a solution that solves your problem in no time. Solution number 2, solve your problem in 1 minute. Solution number 3, solve it in 2.3 minutes. Solution number 10, solve it in 5 minutes. You should go to a solution that solves your problem in no minute, because we are talking about a monster called pressure. He will not wait for you long. He will eat you in no time. So please always find a solution that solves your problem in no time. If you cannot find it, go to a solution that solves it in 1 minute, and so on. But don't start with a solution that solves your problem in 2 hours. Like the gentleman who told me, pull out of the hole and close the swap valve. This will take 2 hours. Someone say, okay, let's scale the well. I said, great, let's do it. So we have the pump, we mix the kill fluid, and then let's start pumping. The surface pressure is 520. So I need to start with 6,000 to be able to kill the well. How come? If 20 psi is forbidden now, you need me to use 1,000 extra? So killing the well definitely is not the solution. Then what's the solution, Ahmed? Cut. Cut your cable. drop it in the well, close the swab valve, secure the well. So people, attendees, when they hear the solution, they cry because, and they tell me, Ahmed, do you know this solution will cost us how many US dollars? I said, I don't care. I care about life. In this course, we care about life. We don't care about money. And by the way, killing the well is the last option you can choose. In my courses, I tell my people two devices, put them in your right hand pocket and zip it. Do not touch them unless you are forced to. These two devices are will kill and cut. This is the last option you should think of. Cut and kill. These are the two things that you should not touch unless you are forced to. And two devices do not touch or use unless you are forced to. Please put them in your left hand pocket and zip it. These two devices are downhole safety valve and the lower master valve. Lower master valve is your Lamborghini. You use it in the weekends only. But during the working days, you go with your Toyota 1990 model because you can afford that, but you cannot afford the cost of the Lamborghini, the maintenance, the running cost of the Lamborghini or Ferrari. Uh, Maybe time will come if we have time. We might be able to discuss this in details, but please keep this in your mind. And these two devices, a lower master valve and a downhole valve, are the last option you use to solve your problems. Talking about pressure, talk about this blowout preventer that we tested to 5,000 psi and we recertified. Let us go to the field tomorrow. We rigged up on the Christmas tree. We are planning to do a job where the maximum expecting surface pressure during this job is 1,000 psi. This is the maximum pressure we will reach during the whole job. Should I test the BOB to 5,000 psi or not? We are planning to do a job where the maximum expected surface pressure during this job is 1,000 psi. Do I have to test the BOB to 5,000 psi? Yes or no? The answer is no, actually. We tested to at least 1.2 maximum expected. So if the maximum expected is 1,000 psi, the minimum pressure test we do is 1,200. Can we do it to 1,500? Of course we can. Can we do it to 3,000? Yes. To 5,000? Yes. To 6,000? No. 5,000 is the maximum. So why we don't go directly to 5,000? If the maximum expected surface pressure is 1,000, each additional one single psi you add, number one is you are creating a hazard. Number two, you are creating fatigue to your equipment. That's why you have to minimize the hazard and minimize the fatigue you create to your pressure control equipment. I know, guys, you might have so many questions to ask me, but this is the bad side of this online courses, which I hated because I'm talking most of the time, I'm talking to the wall, I say. While the practical courses, the normal courses, I'm with my attendees that we can fight all day. I like fighting a lot. Fighting in a sense of talking to each other and having different views. And then I try to convince you, and you try to convince me, and then at the end we fight and we go to the court, which is the API. I am missing this in online courses that I keep talking and you keep listening. But unfortunately, this is how it goes. Let's start with the this topic, barrier. What is the barrier? What kind of well service disaster could happen caused by pressure? It is the blowout. The pressure causes a blowout. What causes the blowout to happen? The barrier you are using failed to do his job. What is the barrier? By definition, it is any device, fluid or substance that prevents the flow of a hydrocarbon. Like what? Like the Christmas tree, like the BOB, blowout preventer, like a wireline plug, we put it in the completion landing nipple, like the stuffing box of the slit line, the grease injection head of the electric line or braided line, like the stripper in the coiled tubing, uh, like the fluid. But when I said fluid, I cannot stop like that. Fluid is considered a barrier if it creates hydrostatic head greater than information pressure within a specific range, 200 to 300 psi, and it has to be monitored all time. The moment you lose monitoring of this fluid, you cannot consider it as a barrier. So it's fluid to be a barrier. Number one, it has to create hydrostatic head greater than information pressure within a specific range, which is, we call it 200 to 300 psi, and it has to be monitored all time. Otherwise, it is not a barrier. What about downhole city valves? The downhole city valve, by the way, it is a must in any producing well now. Is it a barrier or not? Actually, if we close it, it will prevent the flow of hydrocarbon. So, as per the definition, it is a barrier. But we do not, as well intervention or IWCF, we do not consider it as a barrier. We consider it as an emergency barrier. Then the question comes, is there any difference between a barrier and emergency barrier? Yes, it's like if I have $300 in my pocket and $200 in my wallet, if any of you ask me, Ahmed, how much money you have, I have 300. Come on, Ahmed, you have another 200 in your wallet. Oh, I live my life with the $300 in my pocket. When I will start using the 200 in my wallet, when you put the knife on my neck, I will give you my jacket, my trouser, my shoes, everything you like. This is emergency, but I live my life with what I have in my pocket. This is the difference between the barrier and the emergency barrier. So when I tell you we need to rig up on a certain well and we need to have three barriers, when I count the three barriers I'm using on this particular well, I will not count it downhole city valve because it is not a barrier. It is an emergency barrier, and keep this in your mind. And that's why I tell you, it is one of the two devices. You put them in your left-hand pocket and zip it. This is one of them, downhole to the valve. Do not use it unless you are forced to. This is your last sort of defense. Yani, even if you have to use either a lower master valve or a downhole valve, you unzip your and put your hand in your pocket. Which one you take first? Take the lower master valve. Downhole valve is the last option for you to use. We classify barriers into three categories: primary barrier, secondary barrier, and tertiary barrier. Normally, we are working using the primary barrier. In a slick line, for example, our primary barrier is a stuffing box. If it failed, we stop the operation and go to the secondary barrier. Why we stop the operation? Because the only barrier that can work while in and out, while in motion, is the primary barrier. All other barriers you can think of to use them, you have to stop the operation. They work in static, not flowing, not motion, not in motion. So if your primary failed, we stop the operation and we apply our secondary barrier. Our secondary barrier is normally the VOB, throughout treatment. But let us here discuss the word failed. What do I mean by failed? Yani if during the job the stuffing box is leaking, can I say it fails? No. It is leaking. All what you have to do is increase the pressure a little bit. It will stop the leak. But when I consider it failed, when I put the maximum pressure I can apply and it's still leaking, now it is failed. Clear? This point? The difference between leaking and failed. If it failed, which means I put the maximum pressure I can apply, but still leaking, then I'll stop the operation. This is number one. Number two, I will apply my secondary barrier. My secondary barrier is the BOB, the blowout preventer. We close the BOB. The BOB will seal around the wire, preventing well flow. If I apply my secondary barrier and it failed, in this case, I have to go to the tertiary barrier. In the slick line operation, where is the tertiary barrier? Tertiary barrier is the Christmas tree. But which valve in the Christmas tree? In the Christmas tree, we have three valves. We have swap, upper, low. Which one we close to secure the well? Cut the wire and secure the well. All of them, by the way, are gate valves. Gate valve are a knife valve. If there is a slick line, they might. But which is the correct one to use? The correct one to use is the uppermost valve. Why? Because we say some uppermost valve has the wire cutting capability. And if you go to the supermarket to buy a gate valve, and on the shelf you see two gate valves, both same size, same manufacturer, same pressure rating, same color. But one is $1,000, the other one is 1,300. So bring the salesman, what's the difference? Oh, I tell you that the 1,300 is the wire cutter. The difference between them actually is the normal gate valve, when you close it, it is a knife that goes all the way in to seal. So this edge will go to inside the bed and seal. On this strip, if there is a slick line, if it cut it, you're going to damage it because the edge is designed to make a seal, not to cut. If you needed to cut without damage, I'll tell you, leave the valve with me and pass by tomorrow. What I will do is I will go to this edge. I will make heat treatment. So when it cuts, it will not be damaged. But why we put the cutting capability in the upper, not in the lower or the swap? Because the upper valve is the only valve that is working pneumatic or hydraulic. The swap valve is manual valve. The lower master valve is manual valve. Your hand is not strong enough to cut a wire, but the pneumatic or the hydraulic, it has the power to cut. That's why we say some upper master valve can cut the wire. So our primary barrier is the stopping box. Our second, if it failed, we'll go to the secondary barrier, which is the BOB. If it failed, we'll go to the tertiary barrier, which is the Christmas tree. But if we move to the coil tubing, if we put on top of a Christmas tree quad BOB and two-section lubricator or riser, why I said lubricator or risers? Is there any difference between lubricator and riser? For years, I worked with international companies actually, and I was under the impression that both are the same. I mean, what is this? It's a lubricator. Can I call it a riser? Sure. Riser and lubricator are the same. Till I get the knowledge that they are not the same. Lubricator is thread connection. Riser is flange connection. This is the main difference and the big one as well. Lubricator is thread connection. Riser is flange connection. So if we go to coil tubing, we put coil tubing, two-section risers, then our injector, which contains our primary barrier, which is the stripper. In this case, where is our primary barrier? Definitely, it is a stripper. If it fails, we're going to stop the operation, go to the secondary barrier, which is the BOB. Great. Apply the pipe wrap that seal around the pipe. If it failed, we go to tertiary barrier. Where is the tertiary barrier? People start saying shear seal BOB. I do not have in this rig up shear seal BOB. Can I do the job without shear seal? Of course, yes. The API allows us to do that on a certain categories. The low pressure, what we call low pressure categories, yes, you can do the job without shear seal. So where is our tertiary barrier? Actually, it is the Christmas tree. Can the Christmas tree cut the coil tubing? Of course not. Then how it comes? It is the tertiary barrier. It is how to use it. If your primary failed, then your secondary failed, which is your BOB, which is the pipe ram in the BOB. What we're going to do is you go to the secondary barrier, which is your BOB. Ask the BOB to use the shear blades to cut the pipe. When you cut the pipe failed in the well. Now you go to the tertiary barrier, which is the Christmas tree, go to the swap valve, close the swap valve, secure the well. But before you do that, EPI tells you have to pull out at least 10 feet. Why? Because if you are the TD, total depth, you cut, the pipe will not fall, will not fail down. So you cannot use the Christmas tree. So you have to pull at least 10 feet. So when you cut, you are sure that the pipe will fall down, be away from the Christmas tree, allowing you to close the Christmas tree valve to secure the well. And look at what I wrote in green here. Any barrier can be classified as primary barrier as long as it prevents the flow of the well. Yani, in normal case, slick line back to the slick line. Primary barrier is the stopping box. BOB is your secondary. Christmas tree is your tertiary. Yes. During the job, if the primary fails, Then we go to the secondary, which is the BOB. We close to C. After you use the BOB to C, what is the classification of the BOB? It became primary. And the Christmas tree moved from being tertiary to secondary. They keep playing this rule till you fix the primary barrier and you open the BOB. The BOB now goes to be a secondary barrier, and the Christmas tree moved from secondary to be tertiary barrier. I know that 1 hour is gone so quickly, but let us let us see this question. What can happen when you unset a retrievable bridge plug and don't have enough weight above it? The retrievable bridge plug is a wireline plug. We run it through the production tubing. We go all the way down. We pass the production tubing. We go to the open hole. And then this retrievable bridge plug, it has a rubber element that inflates to seal around the casing. We use it to do a certain job. Once we finish, we need to retrieve it out. Before you retrieve it, what is the first thing you should do? Equalize the pressure. And keep this in your mind for your future. You cannot open any device without equalization, without equal pressure. Even the self-equalizing devices, because even these self-equalizing devices, to open them, how they know that you need to open them? You have to give him a certain type of pressure or movement to tell them, I need to open it. So by doing that, you're going to open a little port. And yes, you wait for 15 minutes to self-equalizing. Then, but generally speaking, you cannot open a device unless you equalize the pressure above and below. If you didn't, this is what you're going to see. These are actual pictures taken from that place. You will see a disaster here. You see all these environmental loss. You see these pipes. These are not called tubing pipe. This is an oil well pipe. This is production tubing. What brings all these pipes to the surface? A simple word called pressure. And this is the retrievable bridge plug. They found it. Where they found it? They found it, if you have a meter, to measure the distance between the rig and this device, it is almost 400 meters. This was not there. This was 1,000 feet below. When you open it again, it's differential pressure. The pressure pushes it all the way to the surface, and it flies like a rocket 400 meters away. This bridge plug as a classification, actually, it's the barrier. But if you misuse it, it will create a disaster. If you misuse the barrier, you will have a disaster. The API said that the minimum number of barriers you should use are 2, regardless of the type of operation you are doing, workover, drilling, coil tubing, wireline, snubbing, whatever it is. The minimum number of barriers are 2. That's why we at the well intervention team, when we work with coil tubing or wireline, we use 3 barriers. Why we use 3? Because if during the job we lost 1, we're still under the umbrella of the API. We have 2. But if we use the minimum, which is 2, and during the job you lost 1, you are in deep trouble now. That's why we use at least 3 in well intervention. If you don't mind, I need to finish this topic, so I'll go further a little. If you want to leave, whatever, anyone who wants to leave, feel free to do that. We classify the barrier into 3 categories, but now we are talking about the barrier types. We have 2 types of barrier. We have a mechanical barrier and we have a hydrostatic barrier. Even the mechanical barrier, we have 2 types of these. We have either closed type or closable type. In closed type, it is closed throughout the operation, like the wireline plug, like the stuffing box of the wireline, like the stripper of the coil. As long as you run in the hole or protect the hole, it is closed. This is closed type. But in closable type, it is closed when required, which means it is open by default. It will close when you need it, like in PUB, like in Christmas tree. These are closable type. The hydrostatic barrier, we agreed it is a liquid that creates hydrostatic head greater than information pressure and monitored all time. Otherwise, it is not a barrier. When we test a barrier, this is a rule with no exception. You cannot use a barrier without testing. It is a must that you test a barrier before you use. And when you test it, we need to test it from a direction of flow. We test it from a direction of flow. It is not from below, not from above, not from the side. It is from a direction of flow. Yani, you cannot have a BOB, blind ram, close it, and test it from above. By the way, it will resist, but you damage it because it is designed to, when you close it, to withstand the flow coming from this direction. So you have to test it from this direction. We test it from a direction of flow. I will skip this because time is limited. But general rule of testing the barrier, we test it from direction of flow. We never test with gas or flammable liquid. This is common sense. Be sure there is no air in the system, and you have to get rid of the air because the air will mislead you to the correct reading, pressure gauge reading. Yeah. Do not exceed the maximum working pressure. All tests has to be recorded. Use standards and procedures. Ah, طيب, I'll stop now and start looking for your questions. Question will share slides with us, Dr. Ahmed. Sure, يعني Dr. Ahmed can send you these slides somehow. يعني feel free to take it. No, I have no problem with that. Can you please explain the reservoir pressure buildup part, why it is sharp? Harder. As we agreed that in any flowing well, when the well is flowing, pressure has a passage to go through the production line, production facilities, all the way to whatever the end. But when you shut in the well, the pressure will start to accumulate. There is no place for the pressure to go to escape anywhere. So you are building up a pressure now. And that's why when you shut in a pressure, shut in a well, you shift the case from flowing condition to static condition. To these gases, which at the bottom, it travels all the way up because we agreed that in a static condition, these three main liquid, which is gas, oil, and water, will separate based on densities. Water at the bottom, oil above, and gas above. The gas, while traveling all the way up, it takes the pressure with it all the way up. That's why in shut-in well, the bottom one pressure is the sum of two pressures. The sum of the hydrostatic created plus the newcomer, the gas pressure created at the surface, which is the gas cap created at the surface, causing pressure to increase. And that's why in that curve, the moment you shut in a well, the surface pressure increased sharply. This is because of the buildup of the formation pressure. But then the pressure goes slowly because what is now causing the pressure to increase is the gases. Why it is not sharp? Because you have some gas at the surface, they will take 5 minutes to reach. But some gases are at 200 feet, they will take 10 minutes. Some gases are at 2,000 feet, they will take 20 minutes. Some gases at 10,000 feet, they will take 2 hours. So as long as gases is building up at the surface, pressure is keep going up, but slowly because gas does not come all of a sudden. I hope I answered the question. Ahmed, I don't understand your question. You said little above. What is little above? Uh, Another question, if we cannot use the equipment to more than 5,000, then what's the use of testing to 7,500? I answered this while explaining. I said the difference between the 5,000, which is the maximum operating pressure and or test pressure you do, and the 7,500 is to save your life in case of emergency. Like, for example, while testing, you increase the pressure. You're supposed to test to 5,000, but suddenly the pressure goes to 6,000. Your equipment will not be blown out, killing any person around it. So the difference between the 5,000 and the 7,500 is to save your life in case of emergency. Uh, and don't guys keep your mind that 5,000 is the working pressure of equipment. We have equipment which is rated for 10,000 psi. We have equipment which is rated for 15,000 psi and even more. Uh, Let us see more questions. Uh, why should the downhole safety valve be used only in last resort? As I said, it's like when I go out, I put 300 in my pocket, but keep these 200 in my wallet. These 200 in my wallet, it is emergency. I use it in emergency. I use this system in my social life. Actually, I do that. What about feed? You have to have emergency device, extra devices that can save your life if the normal one does not. And if you go as per the API with two barriers, and during the job the two barriers fails, you are in deep trouble. So in this case, you have a device that can save your life. That's the main reason. Uh, you are an employee taking $3,000 per month. This is your salary. If you don't have a reserve in your bank account, and during the month, one of your children is sick and you need to go to he needs to go to the doctors, from where you got the money? Your salary is dedicated to the grocery, to the supermarket, to the bushler, to the dry clean, to your wife. You have to have something which is hidden. You can use it in case of emergency. This is the downhole safety valve. Ah, if for a slick line operation, it is recommended to use the upper master valve. Which valve should be used for workover? Uh, Workover, you don't have a Christmas tree. In workover, then you have a drilling rig, you have the rig, which is totally not well intervention, because in workover, it is a totally different story. Workover, you are dealing with dead wells. In this course, we are talking about well intervention. If you look at the word intervention in the dictionary, you will see that it means act fast. Because in well intervention, we are dealing with life wells, but in workover, we are dealing with dead wells. So the standards are different. The sequence and design philosophy is totally different. How vacuum is created when surge pressure occurs. Go to the pharmacy, buy an injection, plastic injection, and put it in the medicine, liquid medicine, and you start to do like that. What will happen? You will see the medicine enter your injection, right? Because the vacuum created. This is what vacuum is. You earlier said that there is two devices that you can touch. I said you cannot, not can. When the emergency comes, the case is when pressure exceeds. But any other cases, right? Can you give us more of them or just one, please? I cannot hardly understand the question, but let us talk about. Yes, it is true. I said that there are two devices. Do not use them unless you have no other solution. These devices, two devices, lower master valve and the downhole valve. Because always you have some other devices to use, like an upper master valve, like the swab valve, like the BOB, like shear seal BOB, like the stuffing box, the grease injection head. All these are devices you can use, but keep these two. These two are uh, like the deposit you have in your bank. You put 5,000 US dollar, you don't touch them. You know nothing about them. You live your life with your income, normal income. Where you go to this 5,000 US dollar when you have a disaster, when you need to get married. I'm not saying that married is a disaster, but so you touch this 5,000 US dollar, you have it in your bank. In case of emergency that you have emergency situation you have to deal with and you don't have enough money in your pocket, then you go to this. Otherwise, do not, yeah, don't go to them because you need to buy a new trouser. Do not touch this 5,000 PSI. Go to your salary. This is why we said these two devices do not touch unless you are forced to. Hello, sir. I want to ask about if we produce again the shut well, how long it takes to pressure goes down to before we shut in. I'm afraid that your English data is not clear, but why we shut in a well? We shut in a well for many purposes. Uh, uh, how to produce from this well again? Open the valve. You are producing again. Uh, um, but if you are talking about when we shut in a well, how many minutes or hour it takes to till the well is stable when we have this water down, oil above, and gas on top. This depends on the well character. Yani it varied from a well to another. Another question: why swap pressure occurs? Because of pulling out too fast. If you are pulling out too fast and you don't have enough clearance between the ID of the completion you are running in or running out and the OD of your wireline tools, you are creating this vacuum because you have no equilibrium between the pressure above the tool and the pressure below the tool, and that's why you are creating. It's like injection. It is the simplest way to explain that. It is the injection, the plastic injection. Uh, do like that. This is vacuum. Go back. This is surge. Track pressure, bottom hole pressure. What should be safe? Difference pressure not to damage reservoir. Each reservoir has a fracture pressure limitation. This is well known from your study to the reservoir. So we know that this reservoir, its fracture pressure is 3,250, for example. So this is the red line that we should not exceed. Otherwise, we're going to fracture formation. Fracture formation means that we're going to break the unseen link between these gravels, these grains, and they will be split away, whatever, horizontally or vertically. If at any particular time now you stop pressure, you stop pumping, these grains will fall down, collapse, the well is collapsed. You don't have now any clearance between these grains, so no streets, no roads for the flow, for the hydrocarbon to flow from. The frag job is totally different story. Sometimes we do frag job. Frag job is fracture job. We frag. We know that the formation pressure, the formation fracture pressure is 3,250, but we apply 5,000 or 10,000 psi. So we fractal formation, but we plan to frag. This is a big difference, planning or not planning. We plan. So yes, when we pump 10,000 psi, you split these grains away from each other. So the roads down there, the road that was 2 lanes became 4 lanes. So more hydrocarbons to flow. This is true. But before you stop pumping, you fill this area you create with propant. Propant is an artificial formation you create at surface. You pump it, it fills these gaps. You stop pumping now, the original formation cannot go back because we have you fill these areas with artificial formation which has high permeability. Would share a book on well intervention. I have no problem with that. I will discuss this with Dr. Ahmed Al Garhi, and I have no problem with that at all. Sir, is the hydrostatic fluid in the well not a primary barrier? The hydrostatic head, if it creates hydrostatic pressure greater than the formation pressure within a certain 200 to 300 psi, and you keep monitoring, yes, it is your primary barrier. I think if the well has a blowout, how long it takes to the pressure goes back. If you have a blowout, everything you lost, nothing will go back. Because if you have a blowout, you have to deal with the blowout first. How fast you're gonna deal with the blowout, this is a different story. Mm, Please help describe well shut-in procedures. This is the big topic. I'm afraid it is not part of the course. Uh, how about controlling the well from rigorous operation? Is there only killing fluid or always have mechanical barrier like mini BOB? Not mini BOB, it is a true BOB. When we work with rigless, it is the same like we work in rig. The safety devices are the same. The pressure control is the same. The API standard is the same. The API doesn't make a difference between working onshore, offshore, rigless, not rigless, blue color or red color. So when we work in rigless operation, we follow the same standard. We follow the same procedures. How are self-equalizing devices activated, like a tubing retrievable downhole CC valve? We have what we call self-equalizing downhole CC valve. Uh, when you close, because you have an emergency device, emergency situation, you bleed off the pressure above, you solve the problem you have above. Now you need to open this valve again to start production. But you cannot open it now because above it you have 0 psi and below here you have 3,000. You cannot. If the valve is self-equalizing, what we do, we go to the control line, we apply slow pressure. We apply pressure slowly. This will open a port that size. This port will make the equalization across the valve. We wait 10, 15 minutes. When equalization happens, you continue pumping in the control line to open the flapper. Most of the well, we have bowl type and we have flapper type, but the majority we are using is flapper type. Uh, these all the question I have. Wait, I have in the chats. Looks like let me see if we have more questions here. Good morning, everyone. Dr. Ahmed Zeftawi. I'm not a doctor, by the way. I'm just an engineer. I would like to know what is the maximum acceptable pressure during well perforation, and is there any way to predict gas the gas pressure based on depth? And no way. And you cannot say maximum uh, what's the maximum acceptable pressure during the well perforation because it depends on the pressure control equipment you are using. And that's why this pressure control equipment is categories. We have 2000 psi, we have equipment rating to 3000, to 5000, to 10,000, to 15,000, and even more. So from your study, you should know that, as I said, the relation between this and that should be at least 1.5. So, for example, if you expect that the reservoir pressure, when you perforate, it will give you 5,000 psi pressure. That means you cannot use 5,000 psi equipment. You have to go to 10,000 psi because when you go to 10,000 psi, you know that the pressure, maximum expected pressure is 5,000. And as I said, at the pi, you have to multiply, when you pressure test, at least 1.2 is maximum expected. So you have to multiply 5,000 by 1.2. This will give you 6,200 or so, whatever. And that's why you have to go to the higher category, which is 10,000 psi. Uh, How do you see the future of well intervention in the context of increasing focus on renewable energy sources and in the energy sector? Uh, it's one statement, but it takes time to answer this because there are different scenarios. Uh, what is the future of the field intervention? Because the new technology implemented now is really يعني unbelievable. يعني, uh, up to now, we're still discussing when you drill a well, for example, we use drill bit and drill coolers. And when we uh, produce from a well, we have to run completion, then we have well head. But come on, guys, يعني, the new technology now, we drill with the casing. We drill with the casing. So there is no drill pipe or drill cooler. And once we finish, we perforate the casing and we produce from the casing. So we don't have production tubing, we don't have production accessories like packers and SSD, SPM, landing nipple. But this is a big, big, big story. Can human being personnel be a barrier, especially when he fails to operate equipment appropriately? Uh, Quickly speaking, it happens in Libya with one of the international service companies when they were on site, and a blowout is about to happen, and one of the crew run to the Christmas tree, closed the swab valve, and he was not wearing cover gloves. Uh, he closed the swab valve, preventing a blowout, saving lives, uh, saving environment, saving financial, and he was totally injured. يعني, some stories told me that when he tried to open his hand after he closed the swab, he couldn't because his bare hand was with the swab valve, which was too hot that it caused a burn. And it was, he went to the hospital anyhow for weeks. And at the end, they make him a big, big party. For what? They fire him. They fire him because I'm not talking about now what he said, but he did something we call it unsafe act. And this international company would like other people to follow him. He might die. So you cannot be a barrier. A human being cannot be a barrier. Uh, Please, I just want to ask what is the well correlation? Not part of the course, but quickly speaking, the correlation that if you need to do a certain job at 9,000 feet, so you run to 9,000 feet. Who told you it is 9,000 feet? It's your counter. Who told you that your counter is correct? What is the accuracy of your counter? You are definitely not at 9,000 feet because of so many reasons. One of them is the elongation. One of them is the temperature difference between surface and downhole. One of them, the accuracy of this counter. So what we do, you have to do correlation. Like one of them is what we call landing nipple or tubing end locator, for example. We have some devices that it tells you where you are, and of course we have logging that could tell you where exactly you are. Yeah, but this is a big issue. But this is quickly speaking, what's well correlation, depth correlation. If I understand your question correctly. Last one, which of the following is a common application of nitrogen in well intervention in nitrogen in well intervention, we use it in many reasons. One of them, of the common type of nitrogen, we use nitrogen lift. We need to reduce the hydrostatic head. Like, if for example, you drill a gas well, and you decided to use a completion 4.5 inch, and you start producing this gas. Gas, while coming out from this well, it is not a dry gas. Gas comes normally with two liquids, water and condensate. So the gas, while coming out of the well all the way up, it carries in his hands an oil, water, and the condensate. When he will do that if he has enough pressure to do it. If he doesn't have enough velocity, sorry, if the gas doesn't have enough velocity to do it, what the gas will do, he will close his eyes, open his hands, drop the water and condensate so he can go alone. Water and condensate start accumulating down until it creates hydrostatic head greater than the formation pressure. The well is dead. One of the solutions is to run with coil tubing and start pumping nitrogen. This nitrogen gas will lift the liquid up, reducing the hydrostatic head. So the hydrostatic head became less than the formation pressure the well is producing again. This is one of the way that we are using this nitrogen for in well intervention. I hope I'm done for today. Sorry, I thought it is 1 hour, but it takes almost 1.5 hours. The next session will be Tuesday, same time. We will continue talking about completion operation as well. Hopefully, we'll finish it Tuesday, and then we move to another topic. I hope that I I pass some good or useful information to you in this 1 hour. Yani. Thank you for being there, and see you Tuesday at 6 o'clock.